All right, question number 5 and 6 of proving trig identities, proving the equations are correct. So number 5 is sine squared of x plus sine squared of x times cotangent squared of x, and that equals 1. So hopefully this one seems obvious to start on this side because changing a 1 into other things is going to be very difficult. So let's look at this left side and try to simplify that. The first thing that I notice is both of these terms have sine squareds in them. So something just like in regular algebra with x's, we can factor out a sine squared because they both have it in common. So I'm going to write, in brackets what's left over. So if I take out a sine squared from here, that'll just be a 1. And if I take it out from the second term, it'll be cotangent squared. Okay, so 1 plus cotangent squared. Let's see if that's anything from our trig identities that might be helpful. It seems like it is. In this last one right here, cotangent squared plus 1 is cosecant squared. So that is really nice. It works out for us. 1 plus cotangent squared. That part inside is just now a cosecant squared. Okay, I don't really need the brackets anymore, I guess. But let's change this cosecant into its equivalent. So that's 1 over sine squared. Okay, I like to remember it because the reciprocal functions, so sine starts with an s. Its reciprocal is not going to start with an s. It's the other letter. Sine and cosine is just s and c. Same thing if it was cosine, that is 1 over cosine is the same as secant. So the c one starts with the s. They're like opposite letters. So if that helps you at all, or if you just get it, then that's fantastic. So we change that from cosecant squared into 1 over sine squared, and now, boom, cancel those out, and we just get a 1, which is, that's what we wanted to get in the first place, okay? Question number 6, we have 1 minus this fraction, cosine squared, over 1 plus regular sine. So it's not the same thing as, you can't just add a squared in there, it's not the same thing, and we're supposed to prove this whole side is just worth sine. Again, I'm going to start on this left side because it's a little more complicated. And we have 1 minus a fraction. Let's make this 1 into a fraction also, and then we can combine the numerators together to make it just one big fraction. So I'm going to change this fraction into here, basically be 1 plus sine of x on the top and 1 plus sine of x on the bottom. So that's what this 1 turned into right here, because I want to have the same denominator, so that's why I picked the other denominator that there already was, okay? So minus cosine squared of x over the same denominator. So now let's combine these tops together. So I have 1 plus sine of x minus cosine squared of x, and I'm just going to put it over my 1 fraction now, okay? So I have this. Let's see, I'm trying to get sine all by itself. We can't just cross these things out. First of all, that wouldn't get us what we want, but also we're not allowed to do that unless everything is multiplied on the top and then things are, multiplied by another thing on the bottom. So we can't just cross those out. Let's change this cosine squared. We've been doing this a lot, changing it from the original Pythagorean identity. Cosine squared, let's change that into 1 minus sine squared. Okay, so I'm going to use this part right here. It came from the original, we just moved it around. Cosine squared is 1 minus sine squared. You might want to write these two down if you haven't done that already. So 1 minus sine squared is what this part's going to turn into. Okay, so we got 1 plus sine of x minus the quantity 1 minus sine squared of x. It's all divided by this still, 1 plus sine of x. Okay, so we have that going on. Let's see. Actually, we could have done something that's easier, but it should work out okay anyway. So let's distribute this stuff. Let's see what happens, because this is not what I was planning on doing. Let's distribute this negative sign through, and hopefully we should see it all works out. I'm going to start putting my work up here. 1 plus sine of x minus 1, and then plus sine squared of x over 1 plus sine of x. So it's getting a little tiny up there. What we can realize is these 1s would cancel out because it's a positive 1 and a negative 1. So now I have a sine of x plus sine squared of x over 1 plus sine of x, okay? Just like we did in the previous question, these both have something in common. So let's factor out a sine. And I'm just going to put it in brackets because it's kind of confusing when we have parentheses a lot of times. So left over from here would just be a 1. Left over from there would just be a sine of x. Oops, brackets. Whoa, excuse me. And then we have 1 plus 1 sine of x that was already on the bottom. Now we have some multiplication happening here, so now we can cross out this whole entire quantity over this one, and we just get regular sine of x is what's left, and that's what we wanted. So again, it's not what I was originally planning on doing. Something else we could have done first is this step, we could have combined the 1 and the minus cosine squared and turned that into sine squared, and that jumps us to right here, and we kind of skip a step then. Or actually right here, jumps us to right here. So again, it's okay, you'll get there. It just might take a while or might be a little more complicated than you originally anticipated. So keep going, I'm sure you're doing a great job, and we'll review this for sure next week.